latch or something.
Yep. Alright, so all these tools, so that's normally closed contact, normally open. Off delay timer, so before we had an on delay timer, but here's an off delay. And this is a hash. If this is true, it writes the output, but it also keeps going. So you can use this to write multiple outputs for different scenarios on the one network. You can.
So if you don't have the hash, you can't put two cores one after the other.
You can do. It's a bit hard. You can't. You can bridge out like here and put. I can drop down another network, and I can have another coil to drive something, but that's going to have the same state of logic as this, whereas that output and that output are really independent. So I could put all this on a separate network and have that output just a normal output, or I've got them on the one network and using hash to write to the output. The basic ones are up here, so normally open, normally closed, output, or an empty box. Put the empty box, and if you know what it is, the shortcuts, all your functions are in there. Only useful if you really know what it is. So if you want to do a move, MOVE, and I'm going to move data from MB15, and I'm going to stick it in MB16. So you fill that out. They're also all listed over here. So we've got bit logic. So these normally open, normally closed, and not. What's this one actually called? Midline output.
So what button do you push then to bring the help?
F1.
Just F1.
So F1 for help, or in there. So midline output. So you can read that. Because generally an output's at the end of the network.
Yep.
Reset set or set reset. Negative edge, positive edge. Save, I don't really use. What's that one? So you just click and drag it to where you want to use it. Neg. Address negative edge detection. So that must be like a negative edge bit. Like they might be the same. This has obviously got other bits assigned to it. I've never used this before, so read the manual. Select these. Comparators, so equals integer. So if you want to compare two integers, put your two integers in there. If they're the same, you'll get an output. Not equal, greater than, less than, greater than or equal, less than or equal, and then they're all integers, and you got the same for doubles and the same for reals. So you just keep. I generally just drag them in, press F1, then you sort of read, oh, it's less than. Do I want my small one on top or on the bottom? How am I comparing it? So that helps pretty good for each of those functions. Converters, binary coded decimal to integer, integer to binary coded decimal, integer to a double int. So an int's 2 bytes, same as a word. Converting this to a double int, it'll just pre-fill one side of it with zeros. One thing worth noting is we had to do a byte swap when we were doing communications with Profibus, because Siemens uses different big Indian or little Indian to Allen Bradley. Might talk about that more in the comms function. Converting a double into a real, or what's probably more useful is doing a round or truncate, where actually you're getting rid of the decimal places off reals and putting them into integers. Counters, we saw before that they were using countdown timer, so counters down, counters up. I generally use the function block versions of them. I don't like using this, so a DB call. So if you have data block 5 storing a whole bunch of pallet data, and it's DBB for DB byte 0, and DBB2, DBB4, you should address them in its full addressing as DB5.DBB0. If you get lazy, you can open up DB5 and then just, because it's open in memory, then you just access that data as DBB0, DBB2, without leaving off the DB5. If you do that, you can't cross-reference the data. So they have done it in this code, so expect to find that. So don't use this. Jumps, pretty self-explanatory. Don't use unless you have to. It's used a fair bit in the statement list to avoid executing code. Integers, we can add, subtract, multiply, divide integers, and same again for double integers. Floating points, so these are reals. Absolute, square root, square, exponential, sine, cos, tan.
32-bit?
Yeah, it's over 32-bit, so which is 4 bytes. Same size as a double int. Move data around. Call, so there's calls like if you want to call a function, so FC46 will be called. I've never used any of those. And return, so if you want to exit a function before the end of it, but I've never used that either. Not really nice programming. Shift registers, you're unlucky if you have to use these. Status bits, don't use much of these either. What is that? There you go. So you can do a subtraction, store the subtraction, and also see if it also equals 0. Can be useful. Obviously you can do that itself with doing a subtract and then a compare of M10 to 0, which is how I do it. Be a lot easier to read. Timers, you'll use these a fair bit. So pulse timer. Come down. Pulse for TV for the time, how long you want to pulse for. So if you get the input, how long do you want the output to turn on for? And the output's going to turn on. You can get remaining time in integer format or binary coded decimal, or reset your timer. And each timer's got a timing diagram as to when the output's high or low. So if you say it's a push button wide to the start and you press and hold it in, it will start the timer and the output would be high. If you keep holding the input push button in, the output turns off at a certain amount of time. For this one, if you let go of that push button, the output drops off as soon as you release that push button or that enable. It depends how you want what you want it to do. On delay timer, off delay timer. What's this one? On delay retentive timer. Don't use this one too much, but they're all there.
So if I wanted to find a free timer,
You want to find a free timer? So it's a bit tricky. Not tricky, but you got to be careful. So if I put in a timer here, so SODT, and I'm saying I'm going to use timer 120, to me it looks like that's being used. That's no good. If I go timer 250, which won't be used, to me that looks empty. And I'm just going to put in a time here. For half a second. That's the format for the timer. S5T hash. And I can do 1 second, 1.5 seconds, or you can do minutes as well. I'll save that. So the correct way to go find out what timers are free are options, reference data, display, and we want to look at our timers, so we go to assignment. There's a lot of other reference data available through these different tabs, but for our case we want to look at timers. So here's our timers here from T down to the one we just created of T250. All the white ones are free, they're not used in code. So we've used this one that's free. If we had to come in before, we would have seen that T120 is used, so we wouldn't use that. Make sure you come to this page. I used to get in the habit of going to the symbol table. If I just sort by name, come down to the T for timer. Here's all the timers that have been given names. You can see on the code here, we didn't have to give this a name, so it hasn't got a name. Because of that reason, it doesn't exist in our symbol table. So if you had to come here and said, yep, 250 is not used, and then later on in your program you come down here, or generally it's another function, and you do a on delay timer, and you use T250 and S5T hash 3 seconds. Save that. It's happy, it compiles, it works. Well, it's not going to work the way you want it to. You don't know that it's been used elsewhere. And now if you come into your cross-reference data and updated it, F5 for refresh, it's used. It doesn't tell you that it's used twice. The only way to find out if it's used twice now is to click on the timer here, go edit, go to location. We can see that this timer is written to twice and read to twice. It's read because the output of the timer is read here, but it's written on network 3 and network 5. So if you're having issues with your timer, make sure that it's only written in one spot. Or every time you use a timer, make sure you pick one from this list. The other thing you can get confused about, especially when code becomes redundant, like this project, I can insert a timer to 230 and T230 there, so timer 230. My timer test is what it's called. Save my symbol table. If I close that and come back to my reference and update, T230 is not used. It's got a name, but it's not used in code. So if you're writing something and you say I want to use T230 and you get that, it's already got a name. Because it has a name doesn't mean it's used in code. It's just old used in code. The reference data is good because your timers, counters, this is your inputs. You can see that this input byte, it's read as bits, but it's also read as a word or an int. That's what this line from here down to here this blue section, sorry, this light blue section, that's accessed as one whole word. I'm going to have a guess and say that's the card encoder. Something in there. So there's no inputs mapped to this stuff. We're using some inputs here, some inputs here. I know that these are our safety inputs, so we're using some of those. That's some more safety inputs, and then these are our outputs. So same for outputs. QB260. We're writing an output there that's an analog output or a word output. Then we've got an M area. So this is quite messy, especially what they've done. So here's MB15, so this is our cart data. We not only access the cart data as bits, but of course we access it as a whole byte when we're comparing it to 0 and moving it along. But I also look at the individual bits, because if that bit here is set, then I know that it belongs to the sticks. If this bit here is set, I know it belongs to bulk line. Not a good way of doing it. Some more memory bytes that are addressed as these are double words, words or integers. And your memory bytes, it's not unlimited, your memory area, but it's quite limitless for practical uses. So you could, of course, and it's all there predefined, so I could say M3005.4. I'm going to save and compile that. It's refreshed my reference data, and there's none of the memories used until I come all the way down to the bottom, and it says, hey, you've used memory byte 3005 bit 4. So obviously there's plenty of memory there to use. Ideally you store a lot of your memory in DB so they're grouped together and you know where they belong to.